In this lesson, we're going to consider another halfway house between monopoly and competition. This one's called oligopoly. It's a situation where there's more than just one firm in the industry, but it's still just a few, just a handful, and not many as there would be in a competitive industry. So here's the general idea. We want to develop a model of an oligopoly in this situation where there are just a few firms. If there were two, it would be called a duopoly. But there can be three or four, but it's a handful. The concept here, there will be limited entry, so we won't have, as we had in the case of monopolistic competition, the ability for firms to enter this industry. It'll be restricted for one reason or another. And also we're going to mostly emphasize there's one product, homogeneous product, but it could be differentiated. It's not really that important to be exactly the same product. And so there are going to be these differences, in particular from competition and monopoly and monopolistic competition. Again, the difference from competition is there's a few firms rather than many. The difference from monopoly is that there are just a few firms rather than one. And the difference from monopolistic competition is there's probably fewer firms, but more important, there's no ability to enter this business, or it's basically fixed in terms of the number. So to analyze this, we have to do a few new things. Actually, not new diagrams, not new curves, but something new. And that newness is going to have to do with the fact that there may be interaction between these firms. If you like to think about a strategic interaction, they're going to have to figure out what the other firm is doing, because there's just one or two other firms out there. And so what those other firms do is really going to matter for each individual firm. So that's the strategy, if you like. And it's a little bit like a game theory, economists and others call it game theory. In fact, game theory helps us understand a little bit about what goes on. Now, we don't need to delve into the intricacies of game theory, but we can consider a particularly famous game to illustrate what's going on. And that famous game is illustrated with this concept of the prisoner's dilemma. So let's look at this prisoner's dilemma and try to study it. The idea is that there were two people who committed a crime. Let's call them Sarah and Steve. We know they committed the crime. In fact, the police and the courts have evidence that they committed a crime. It was a relatively small crime compared to the crime that they actually committed. And for this more serious crime, the police and the courts do not have sufficient evidence. Sarah and Steve have now been arrested. They're in jail, and they can be sent up to prison, up the river, for the less serious crime. Or, depending on whether one of them confesses or not to the more serious crime, they can be sent up to the river for a longer period. The numbers in this diagram illustrate this. So in the top part, we have Sarah, and her choices are to confess to the crime, to the more serious crime, or to not confess, to remain silent. Those are her two choices. Steve also has two choices, exactly the same two choices. He can confess, or he can remain silent. And the two entries are shown to indicate that. Now, depending on what they do, they may go to jail for shorter periods or longer periods. And the numbers in the table indicate the number of years in jail they will get, depending on what happens. So in the very upper right-hand side of each of the boxes, you can see the number of years in jail for Sarah. So for example, in the upper right here of that box is what happens to Sarah if she confesses and if Steve confesses. Over here is what happens to Steve. He's in the lower left of each box, in this case if both of them confess again. Over here it tells you what happens to Sarah if she remains silent and Steve remains silent. Here's what happens to Sarah if she remains silent and Steve confesses. Here's what happens to Steve if he confesses. And Sarah remains silent, and so on. So that's the nature of the game. Now, why does these numbers make sense? Well, let's think about it. If they both remain silent, then they go to jail for the 3 years. because they can't get them for the more serious crime. So they just go for the 3 years. If they both confess, then that's in the upper left-hand box. If they both confess, that's both confess in this period, in which case this is relevant, then they both go to jail for 5 years. That's the more serious crime. And the interesting cases are what happens when one remains silent and one confesses. So let's consider the case where Sarah remains silent and Steve confesses. Then in this case, she's going to have to go to jail for a long time. She didn't cooperate, but they know she did it because Steve confessed. On the other hand, if Steve confesses and Sarah remains silent, Steve gets a good deal. He gets time off for confessing, and he only goes up for 1 year, which is even less than in the case of the less serious crime. And the reverse happens, of course, in the case of the Steve remaining silent and Sarah confessing. That's Sarah confessing and Steve remaining silent. In this case, you can see that Sarah, she's up in the upper right, she gets only 1 year, and Steve, who remains silent while she confessed, has to go for 7 years. So it makes kind of sense what's going on here in this picture. Now let's think of this strategic interaction. And remember, our goal here is to describe two firms in an industry interacting. So to get there, we want to think of these two prisoners. Now, what they have to think about is what the other prisoner will do. And they want to do the best they can no matter what the other prisoner does. So you could, for example, consider the decision of what Sarah should do. Should she confess or remain silent? Well, if Steve confesses and then she should confess too. So for example, if you look over here, if Steve confesses, then you're in this comparing these two things. And if she confesses, she gets 7 rather than 7. She gets 5, rather than 7. And so she should confess. She goes up for a shorter period of time. If Steve remains silent, those are her two choices. And well, again, she should confess because she gets 1 year rather than 3 in that case. So Sarah's strategy is pretty clear. She should confess based on just this idea that she doesn't know exactly what Steve will do. And you can see the same thing is going to be happening for Steve as well. Now, if somehow they could get together and agree that we're both going to remain silent, and Sarah say, I'm not going to confess, Steve says, I'm not going to confess either, so they are able to cooperate with each other and come to a commitment, then they're better off in the lower right-hand picture because they both get 3. But on the other hand, if they can't get together and cooperate, they're going to follow the strategy I just indicated, which means both confess, and in that case, they're going to be up there. So the idea here is that by somehow cooperating or agreeing, they're going to get 3-3, but there's this temptation, this strategic decision to confess, and unfortunately, both confess, they both go to jail for 5 years rather than 3. So that's the prisoner's dilemma. Now, the prisoner's dilemma is very close to the situation that firms operate in an oligopoly, and in particular, in a duopoly, because we want to consider 2. So let's do this. Same kind of picture. Let's call the firms Sarah and Steve. And in this case, we're going to put in the picture profits rather than years in jail. So higher numbers in this case are a good thing. More profits. 0 would be like 0 economic profits, if you like. So in this case, the decision for Sarah is pretty simple. Let's make it. She charges a high price, a high monopoly price, or a low price, a competitive price. And Steve, same thing, high price or low price. If they both charge a high price, they're kind of operating together, they're kind of colluding, and they get 50. They kind of split the market. If they agree to do a high price and Sarah comes in with a low price, that's in the case where she does low and Steve does high, then she gets all the business, she gets everything, and Steve gets nothing. On the other hand, Steve does the same thing if they agree to do high prices, and then Steve, if you like, reneges. In this case, he's going to do the 100 and she's going to get 0. And so the dynamics are quite similar to the prisoner's dilemma. If they could somehow agree to cooperate and stick together, then they do this high price thing. If they are tempted to go to the low price, they're likely to end up in the area down here, which is almost like competition, right? They both charge the low price. So that's the nature of the strategic interaction, and it's so similar to the game. Now, the question that we always want to raise in the case of these kinds of situations is, what will actually people do faced with this strategic interaction? What will be the temptation? How strong is it for Sarah to try to charge the low price, or for Steve to charge the low price in the situation where they really can't agree? There's a way in which they cannot commit completely. So I want to show you yet another game that's very similar to the duopoly game, where you can see some of the pressures that exist, and they may apply to the model of duopoly as well. This is a game that's called Golden Balls. I want to look at a little video to illustrate this game.